So this is not going to be largely different than what we did last time. So do you remember how I said, if you pick the wrong thing to let u equal, if you just keep trying, you'll eventually come up with the right thing. They work together like puzzle pieces. So I said, let u equal either the thing with the highest power or the insides, like the guts of the problem. I'm going to add to that, if you have absolutely no idea, you need to let u equal the denominator. So again, that's kind of like your list, the thing with the highest power, the guts of it, like the insides, because you're doing a chain rule in reverse. Or if you're not sure, the denominator. So in this case, in the x squared is the highest power anyway, we're going to let u equal x squared minus 10. And from there, it's just a process. Like just do the process and you will get your answer. What is your derivative of x squared minus 10? 2x, and you even said dx. Fantastic. Now that will show up in the problem. It has to. If it doesn't work, it's an undoable problem. Now you can't adjust a variable, so the x is right there. Dx is going to just be there. Good, we're going to do a half of that. And here's where I highlight. And again, you're not allowed a highlighter on the AP exam, so you don't want to become too dependent on this, but it does help to see it. In place of x dx, we're going to substitute 1/2 du. So in place of what I highlighted, we're going to put 1/2 du. So you want to put the 1/2 out front, the du at the end. What you didn't highlight is still there. So what is still there? U, but it's where? The bottom. So it is 1/u. So what is your antiderivative of 1/u? Good. So bless you. It is 1/2 ln of u plus c. And again, I don't always say the absolute value because it's a mouthful, but it has to be an absolute value there until you plug in an actual number. All right. And then your last step is to put this stuff back in for u. So your final answer is 1/2 ln absolute value x squared minus 10 plus c. And I hope that doesn't really feel new to you. I hope you're like, isn't that kind of what we learned last time? Yeah, the only difference is I did one that has an ln. Okay. So let's try that again. What's different about this problem versus the one we just did? Yeah, a definite integral. So we're going to do upper minus lower. That's fundamental theorem of calculus. When you get an actual answer, what does that number represent? We'll go back. Derivative means slope. Integral means area. So that numeric answer you get represents an area. All right, so what do we want to let u equal for this one? Yeah, the bottom, x cubed plus 4. Also, it is the thing with the highest power. So derivative of that, 3x squared dx, good. And then you got to find that in the problem. You might need to adjust a number, but it's going to be there. What do we need to adjust for this one? Good, perfect. Multiply it by 2. You get 6x squared dx. Common mistake that's been happening is with these ones that have the boundaries, you don't have to plug this stuff back in at the end. That's the trade-off. You have to do an extra step of upper minus lower, but you don't have to mess with this again. So you don't, like, you can skip that step, all right? 2 goes out front, du goes at the end. What's still there? 1/u. And so it's going to be 2 ln u. Don't put plus c. Instead, it's such that 0 to 3. And again, you don't plug this stuff back in. That's the trade-off. You don't have to do that step. You have to do upper minus lower, but you don't have to plug that statement back in for you. So we're going to do upper minus lower. Yeah, you can't. Oh, I didn't adjust the bound. Oh my gosh, horrible. I'm so sorry. Blasphemy and sacrilege. I was about to catch it though, because I was like, you can't ln 0. Hold on a second. You have to adjust the boundaries. It's not hard, but it's very easy to forget to do, as I just illustrated for you. Thank you. Oh my goodness. So you're going to take the 0 and 3 and plug them in. So if you plug in 0, you're going to get 4. If you plug in 3, 3 cubed is 27 plus 4 is 31. I can't believe I just did that. Most of the time though in math, if you forget to do something, you'll catch it because something weird will happen. And I was about to catch that because I was like, hold on, you can't ln 0. So if you're paying attention, you'll catch stuff like that. Now, when you plug in a number, you can drop the absolute value because the absolute value of 31 is 31, right? So it's 2 ln 31 minus 2 ln 4. Now, well, I was about ready to say, I'm fine with you stopping there. Delta math doesn't, okay? So I'm going to show you how it works. And if you get this far and get stuck, just come up and I'll help you with it. But let me show you how it works. Now, this one won't work out, so I'm going to make up a different one. Just draw like a squiggly line, and I'm just going to give you an example of one. It's not this problem, but just an example of one, because they will make you type it like this. And it's not hard. If you can multiply and divide numbers, it's not hard. But you have to remember your log properties from last year, and nobody ever does. And I get that. It's fine. That's why I'm going to show you right now. Do you see how this is subtraction? That means you divide the numbers inside. So what is 24 divided by 8? 3. Is 24 divided by 8 difficult to do? No, it's not hard. That's my pep talk. It's not that hard. So you get 2 ln 3, 24 divided by 8. And then you're allowed to take this coefficient and put it back as the power. So it's actually ln of 3 squared. And what is 3 squared? 9. So they have you type it in like that. Again, if you get here, you've done everything I feel you need to do. I can't change this in Delta Math. It's how the system works. So if you get stuck, wading through that, just come up and I'll help you with it, okay? I'm not worried about that, but that's how you have to type it in. All right, what do we want to let u equal on this one? If you're totally stuck, what did I tell you to let u equal? The denominator. So it's tangent x plus 7. It's either the thing with the highest power or the guts of it, or if you absolutely aren't sure, the denominator. If you're like the secant squared has the highest power, that kind of goes out the window with trig. Trig is different, right? What is your derivative of tangent? Oh my gosh, secant squared. You actually don't even need an adjustment on this one. So we're going to replace secant squared x dx with just du. It does bother people sometimes when there's not an adjustment number. If you think that's going to bother you, just put like a 1 out front. And so what's left? 1 over u. Good. So what's that antiderivative? ln of u. I'm going to try and get you to skip this step. You can write ln u if you want, but it's going to be ln of tangent x plus 7. And then at the end, let's see. Cool. We'll do these two and then we'll do our like halfway break. What do you want to try and let u equal for number 4? So let's talk through that. If you let it equal cosine, what's the derivative of cosine? Is there a negative sign of something in the problem? No, so that won't like fit together like puzzle pieces. You think through that. What's the derivative of what I'm taking? Does that show up in the problem? Square root of x. Good. Now we haven't talked about this one in a while. This was one I tried to get you to just memorize the derivative of square root of x because otherwise you have to deal with 1/2 and negative 1/2 and it becomes really messy. Does anyone remember it? It is 1 over something. Yeah, good. Perfect. 1 over 2 square root. If you didn't remember it, that's fine. We just brought it up again now. It's 1 over 2 square root. Now, do you see how there is a square root of x in the denominator over here? Good. But there's not a 1/2. So times 2. Again, you can't adjust a variable. And you can never like kick a variable out of the integral. You know how we put coefficients out front? You can do that. Like numbers is fine, but you can't do that with variables. So this square root of x in the denominator and the dx is what we're able to highlight. And in its place, we're going to put 2 du. So what didn't we highlight? What's still there? Cosine u. Perfect. So you need to come up with a function that if you did the derivative, you would get cosine. Just sine. Derivative of sine is cosine. So it is 2 sine of u plus c. And then what's your last step? Yeah, plug in like that stuff for you. So it's 2 sine of square root of x plus c. I can't believe I didn't change those boundaries. I'm still thinking about it. Oh, well, I'm actually kind of glad I illustrated that for you because that's what happens if you don't do that. I know this one looks scary. As a heads up, it actually won't end up being that bad once you do the substitution, but you have to figure out what to let u equal first. So I'm going to let you struggle for a second. What do you think? More than just x squared. You'd want it to be the sine x squared. What's the derivative of sine? Cosine, and that shows up in the problem. You don't want the 3, okay? So derivative of sine is cosine. I'm going to leave a little gap there, though. Because what rule do you need? Yeah, good. It is chain rule. So you would chain on a 2x. I just put it out front. I did that kind of quick. Do you get where the 2x came from? Derivative of x squared, okay? And then dx. Phew. Okay, now you go and look for that in the problem. We have an x. That's good. Good, 1/2. So 1/2 du equals x cosine x squared dx. And watch, this actually turns out awesome because you get to highlight practically the entire thing. Like you get to substitute almost all of it. And again, that's the point of a substitution, is to make it look a lot simpler. We're going to get to highlight the x and the cosine x squared and the dx. All 3 of those things are going to go bye-bye. And in its place, we're going to put 1/2 du. Good. Now you need to figure out what's still there. U cubed. Good. Now don't forget to actually do the antiderivative, because I totally get why this happens. People feel like they've already worked hard at that point. Like you feel like you already did a problem, so we should be done, right? You have one more step. You have to actually do the antiderivative. So it would be 1/4 u to the 4th. And actually there's one more step after that because you have to plug back in. Good, times 1/2 and plus c. So out front, that would be 1/8. Now be careful how you write this. When you plug back in for u, it's sine to the 4th of x squared plus c, because it's the sine function you're taking to the 4th, not just the x squared. I mean, you've all stopped listening to me because I said we were going to do a break here, but do you understand the difference? Because it's subtle, but they're different. Okay. All right, if you could go down to the bottom of the paper real quick, we're going to write out the ones we know so far, which is actually just sine and cosine, but I'm going to show you the other ones, okay? You need a function that if you did the derivative, you would get sine. Good, perfect. You guys thought before you answered. Negative cosine of x plus c. That's because the derivative of cosine by itself would be negative sine, so you need the negative to adjust for that. All right, you need a function that if you did the derivative, you would get cosine. Fine, good. Derivative of sine is cosine. So those two didn't really involve like any teaching. Once I taught you the derivatives, those are the antiderivatives. You just do it backwards. All right, now I'm going to show you the other 4. So we're going to come over here and do tangent. You can't just work tangent backwards. It's not able to do that. So what we're going to do is rewrite the problem. So I'm going to keep the integral symbol. And I'm just going to throw this question out and see what I get back. I'm going fishing. How could you rewrite? Good. Okay, cool. Sine over cosine. And then we're going to do a u substitution. So what did I tell you to let u equal? If it's like your Hail Mary, if nothing else works. The denominator. Good. So du, derivative of cosine, is negative sine. Thank you, dx. And then what? Yeah, deal with the negative. So you can just erase it and put it on the other side, or you could rewrite the whole line if you want to, but it just goes on the other side. So if you're highlighting, we're gonna highlight sine of x dx, and in its place, we're gonna put negative or -1, if you want to put a 1 in there, du. So negative out front, -1 if that pleases you, and then du. What's still there? 1 over u. What is the antiderivative of 1 over u? So the answer is negative ln. Good, and I was going to try and get you to skip that step. Don't write u, just go ahead and put cosine back in there, plus c. So you can go ahead and on your list at the bottom, that is the antiderivative for tangent. Negative ln cosine x plus c. Well, I was about ready to say, and hold on because I can't talk and write this at the same time. I actually don't memorize that. Here's what I do in my head. I go tangent is, how do we rewrite? Sine over cosine. And I'm like, okay, cosine's the denominator and I would need a negative. Negative ln cosine. That's how I do it in my head without having to write anything down. I just think through the steps we just did. Or you're welcome to memorize it. So here's how I would think through cotangent. How would you rewrite cotangent? Okay, that would be cosine over sine. The derivative of sine is just cosine, so it's positive ln sine of x plus c. So again, I don't memorize those ones. I just kind of think through how it would work out. Okay, these two, a proof exists. I don't know what it is. You are welcome to Google that. I have before. I don't think it's pretty. All right. So these two I do just memorize. Who is secant's buddy? Secant goes with tangent and still the same. Good. It's ln absolute value secant plus tangent plus c. Again, you're welcome to do with that what you want. I'm showing it to you. I feel like I've seen that one once on a multiple choice. This one I don't think I've ever seen, but who is cosecant's buddy? Cotangent, and this one's negative. Negative ln cosecant plus cotangent. So anyway, there they are. I've taught them to you. We can check that box. We're gonna do one more problem together. So go back up to number 7. Oh, what does 7 have with it? Boundaries. We're gonna get an actual numeric answer. You need to let u equal the insides, like the guts of the problem, which is actually very simple. It's just 2x. You don't want u to be very complicated because you have to take the derivative of it. So du is just 2dx, and you would adjust it with a 1/2. If you're like, but Miss Cole, there's a 2 in the problem. The 2 would need to be a coefficient out front. That 2 is inside the cosecant, so it doesn't work that way. Okay. All we get to highlight for this one is the dx, unfortunately. So in place of dx, we're going to put 1/2 du. What's still there? Cosecant of u, and I'm going to remember to adjust the boundaries this time. You're going to plug these in for x right here. So the only thing you're going to do is multiply them by 2. So for pi over 8, that would give you 2/8, would be pi over 4, and then 2/4 would be pi over 2. And you should be like, even though I know you're not happy about this problem, you should be happy about those because why? Yeah, they're on unit circle. Okay, so we'll actually be able to do that. Antiderivative for cosecant. Well, look down here. Do you see how it's negative? Okay, so we're going to have -1/2 ln cosecant u plus cotangent u. Don't put a plus c. Instead, it's such that pi over 4 to pi over 2. We'll do upper minus lower. And you're going to be okay. Promise. Right, so upper minus lower. I'm leaving a lot of space for this. Where's pi over 2 on the unit circle? At the top. Here, you know what? I will even draw it for you so that you can see it. What's that point? 0, 1. Good. Okay. So we're going to have negative a half ln. And you can put absolute value if you want, but once you plug in a number, you can drop the absolute value because it's a number. You make it positive. Cosecant means you're going to flip the y value. If you flip 1, it's 1. Very good. Plus cotangent, watch me point to it. Cotangent is x over y. So 0 over 1 is just 0. And I have even better news. 1 plus 0 is 1. And what's ln of 1? That entire thing just goes away. All right. Now we're going to do the other one. Negative a half ln. Now we're going to do pi over 4. Pi over 4 is right here. That point is square root of 2 over 2, comma, square root of 2 over 2. Do you remember that? Okay. It was last year. It wasn't that long ago. All right. Cosecant means you're going to flip the y value. If you flip square root of 2 over 2, you just get square root of 2. I usually just try to coach everyone to remember if you flip that, it's just square root of 2, because otherwise it's really messy with the 2's. All right. Plus cotangent is x over y. Anything over itself is just 1. And the only thing you could do to make that look any better would be what? Yeah, like the negatives are gonna cancel out. Did someone say distribute ln? That's not a thing. You can't do that. And that's a number, right? Like if we were allowed a calculator and typed it in, that's a number that represents area. Very good.